Hello everyone, welcome back. So today's topic is financial maths and we will be exploring compound interest. Uh, Before we start exploring compound interest, I would like you all to review few concepts. Recall, what is interest? So interest is basically, it is cost of using somebody else's money. What does it mean? So let's say you deposit $5,000 in a bank. So since you deposit it in the bank uses it for various other investments. So your money is used by somebody else. So you are paid interest. And if you borrow some money, then what happens? You are using somebody else's money. So you pay interest. So interest is basically cost of using somebody else's money. Now, how much money? How is this calculated? There are various methods to calculate interest, like simple interest, compound interest, etc. So today we will be exploring compound interest. Before that, let's look at simple interest. What is simple interest? Simple interest is the interest that is calculated on the original sum of money. Now, what is this original sum of money? Let's say you invested $5,000 in a bank for 10 years and you are getting 5% simple interest. It means every year you will get 5% of your deposit, that is $5,000. So every year the interest will be calculated on $5,000. That is original sum of money. This is called simple interest. To calculate simple interest, we have a simple formula. That is PRT over 100, where P is the money that you deposited, we call it principal, R is the rate of interest, and T is the time period. Right? Now, the second type of interest is called compound interest. What is compound interest? Compound interest is the interest that is paid or calculated on the most recent value of the money. Now, what is the most recent value of money? Let's say you deposited again $5,000 in a bank. So, and bank is paying you 4% interest. So, after 1 year, you have already earned 4% of 5,000. That is $200. So, after 1 year, what is the value of your money? 5,200. So, second year when the interest is calculated, it won't be calculated on the original sum of money. It will be calculated on 5,200, that is the recent value of the money. And this is how we calculate every year. So, when we calculate the interest in this fashion, we call it compound interest. Right? Moving further. Compound interest is calculated with a formula. This is the formula where amount P, that is the final amount of money received, is P times 1 plus R over N raised to the power of NT. Here P is the money that you deposited, R is the rate of interest. In this formula we write in percentage. So if it is 6%, we write it 0.06. N is the number of times interest is applied. Sometimes this interest is calculated once in a year, sometimes twice in a year, thrice in a year. So we call it half yearly, quarterly, monthly. So accordingly, N will change. We will see how N changes soon in an example. And T is the duration or the time period, duration of the investment, right? So let's explore it with the help of an example. Here is an example. $1,000 is invested in an account that is paying compound interest at a rate of 6% per annum. Calculate the amount of money in the account after 10 years if the compounding is annual, quarterly, or monthly. Annual means every year you are calculating interest. Quarterly is in every quarter, that is after every 3 months. In 1 year there are 4 quarters. So after every 3 months you are calculating interest. Monthly means at the end of each month you are calculating the interest. So what will be the amount of money in the account? So this was our formula. So in first case, when it is annual, P will remain 1,000 in all the cases. R will remain 6%, so 0.06 in all these cases. T, time is 10 years. It remains 10 in every case, but the N will change. If you are calculating it annually, means once in a year, N becomes 1. Quarterly, 4 times in a year, N becomes 4. And monthly, then N will become 12. And how will this look? This is how it looks when you do it annually, quarterly, or monthly. For annual, we use this formula. T remains 10, P remains 1000, R remains 0.06. In first case, N is 1, so this is your answer. When it is quarterly, N is 4, this is your answer. And when it is monthly, N becomes 12, and this is your answer, right? So that's how we can calculate with the help of a formula. Now, the same question, if you have access to a graphic calculator, in MYP class, you may use a graphic calculator. If you are doing IB Diploma, if it is ASL, analysis is standard level, paper 1, you have to use this formula. But in paper 2, any paper 2, or in analysis applications, I mean both the papers, you may use calculator. So let's explore how do we do this with the help of a calculator. Now what happens in a calculator using a graphic calculator? You know, all graphic calculators, whether you have a TI Inspire CX2 or CX2T recently, or you have TI-84 Plus, or you have Casio CG50 or CG100, or you have a Numwork calculator, or you have HP Prime calculator. In all these calculators, they have a finance app, and in all these apps, you can find compound interest in similar way. So if you know in one calculator, means you know in every calculator. This is how it looks in TI Inspire. This is how it looks in TI-84 plus CE. This is how it looks in HP Prime. This is a screenshot from Casio, and that is a screenshot from Numwork. Now you see in each of these calculators, you have N, and all these represent number of payments or the time. You have I%, that is interest, it is I everywhere. In Numwork, they write R, otherwise it's all I's. PV is the present value, it is PV here, PV here, PV here, PV here, PV here. PMT is for the installment that we won't be using in compound interest. FV is the future value, it is all over. PYCY is everywhere, PYCY, PYCY, it's all over. So let's explore the last question that we did with the help of one of these calculators. Now in TI Inspire, it is finance solver. It is not hidden, it's obviously there in menu. It is again, you have your TVM solver in TI-84, all these finance apps. If you cannot find finance app in your calculator, just send me a message and I'll guide you through all the steps. So let's explore with the help of one of the calculators. Same question we are doing. $1,000 is invested in an account paying compound interest 6%, and after 10 years, if it is compounding annually, quarterly, or monthly. So let's start with a TI-84 Plus calculator. In TI-84 Plus, if you go to apps, in apps, there is a TVM solver. You go to TVM solver and this is what you see. N, I, PV, PMT, FV, PY, CY, and PMT at end. Always keep it at end. N represents the time. It is 10 years. So put N is equal to 10. I is rate of interest. It is 6%. We won't put 0.06 here. We use that in the formula. Out here we just put 6. PV. Now PV is the present value. That is your investment. Now, since you are investing $1,000, so the money is going away from you. So PV, write negative 1,000. And if you're borrowing, then money is coming to you. So you write plus 1,000. FV, leave it blank because we need to find it. PY and CY. This is very important. If it is annual, means your money is accumulating once in a year, so CY will become 1. Keep PY and CY same to start with. So when PY is 1, CY is also 1. So fill in all the values. Take your cursor to FV, that is future value. In TI-84 plus CE, take your cursor to FV, then press in this calculator, you'll press alpha and enter. What? Alpha and enter. Alpha is this green button here, right? This green button. When you press alpha and enter, this is what you see. So this will be the interest, 1790.8, not interest, I mean the amount, the future value. And you see your present value was negative, right? So this is how we do this. Second part, quarterly. In quarterly, your interest will remain same. Interest rate, PV will remain negative 1,000, but PY and CY will change. How will they change? Since it is happening quarterly, means 4 times in a year. So make PY is equal to 4 and CY also equal to 4. Now N is 10 years. How many quarters are there? In 1 year there are 4 quarters. In 10 years there are 40 quarters. So it will become, out here N will become 40, 40, because we are counting in terms of quarters. So this will become 40. PY and CY will be 4 each. I will remain same. PV will remain same. Again, take your cursor to FV. Press alpha and enter, and this is what you see. This will be your answer, right? So now what happens when you work with monthly? PY and CY, they will both become 12. And how many months are there in 10 years? 120 months. So you fill in all these values, take your cursor again to FV, that is future value, alpha, enter, and this is what you see. So that's how we can calculate simple interest, compound interest in a very, very efficient way with the help of a graphic calculator. Now, another approach. Instead of changing both PY and CY, we know that the payment is accumulated every quarter, but the payment is made every year. So if we keep this PY 1, then you don't need to change your time into quarters. You can keep 10 years, just change PY to 1 and CY remains 4. So how will this look? It is 1, 4 and remains 10, and you will get the same answer. Similarly, have a look here. When it is monthly, so you can make CY 12, keep PY 1 and time can remain 10. So you will get the same answer here also. So this is how we can use a graphic calculator to calculate compound interest. Now, let's say in a question you are given the future value, you are given present value, you have been given interest, but the time is not given. Then what do? You fill in other values, any parameter which is unknown. Take your cursor there, press alpha and enter, and you will get your answer. It's that easy, right? So try a few questions, and if you have any difficulty, please drop in comments and I'll address to that personally. So that's all in compound interest. If you found this video useful, consider subscribing it. Please like it, share it, and don't forget to press the bell icon so that you're the first person to get the notification when a new video is released. You can also reach me at Jalaj Maths on Instagram. That's all for now, and Till we meet again, take good care.